So we're given this limit as n approaches infinity. And on the discussion sheet, the indexing variable used is k. That's because our previous textbook for Math 17a used k instead of I. So I'll go ahead and switch it to I so that it matches what we're doing in our current textbook. So we're going to have I equals 1 to n over n squared plus k squared. What we've been asked to do is take this and turn it into an integral in order to evaluate the sum. So thinking about what this should look like as a Riemann sum, I'm expecting to find some kind of delta x and some kind of f of x star, where my delta x is going to come from b minus a over n, and that x star is going to look like a plus I delta x. Well, right now there's not anything in this problem that looks like a delta x. So the very first thing I'm going to do, because I know that I need to end up with something over n, I'm actually going to take the largest power of n in the denominator and divide every term by that. So I'm going to divide every term by n squared. If we simplify each of these parts, that n over n squared is going to turn into 1 over n, which I'm going to just pop down here in front. Then I'd have a 1 on top. N squared over n squared is 1. And k squared over n squared, I could rewrite to say k over n squared. I now know two things. I know that b minus a is equal to 1, so whatever is happening with our integration, these values should be 1 apart if 1 over n is my delta x. I also know in here that probably our easiest option, if that k over n is going to be my x star, that must mean that a is 0. So again, if I'm seeing that k over n is my x star, then that would have to be 0. Oh, I mixed my variables up, the k and the n, the k and I. Let me switch that back. I. Okay. So that I over n is my x star, which means this should look like 0 plus I times 1 over n. I now know that my a is 0, and because b minus a was equal to 1, b must be 1. That means that our function is sitting right here, and our function looks like 1 over 1 plus x squared. Last step, because we were asked to evaluate it, we need to find the antiderivative, and 1 over 1 plus x squared, that's going to be tan inverse of x, or arctan of x. And then we're evaluating from 0 to 1. When we're evaluating arctan, this is asking us the question, tangent of what angle is equal to 1? And the answer to that is pi over 4. This is then asking me tangent of what angle is equal to 0? And that angle is 0.